This is another practice problem on operational amplifier. And in this question, we are interested in finding out the expression for the output voltage where the op-amp should be treated as an ideal one. So, like in my previous videos, you will also find that here there is a presence of a voltage divider. The voltage dividers are very common to op-amp circuits, and invariably in every other circuit you will find the existence of a voltage divider, whether it is connected to the positive input terminal or whether it is connected to the negative input terminal. So recall that a voltage divider is given like so, where you have, let's say, a biasing source here which is Vp volts, and then there are two resistances which are in series. There could be more than two resistances, but invariably in the circuits that are provided in gate, they have two resistances like so, and we are interested in this midpoint voltage because this midpoint will be connected either to the non-inverting input terminal or it will be connected to the inverting input terminal. So the voltage at this node is given by Vx, which is equal to the resistance R2 divided by sum of both these resistances, and then it is multiplied by Vp. So once we follow that approach and we have figured out that this is the voltage divider, therefore the voltage at this node will be given by R divided by R plus R multiplied by V naught, which is equal to 0.5 times V naught. So the voltage at the inverting input terminal of this op-amp is equal to 0.5 V naught. From the concept of virtual short, we also know that the voltage at the inverting and the non-inverting input terminals will be the same if there is presence of negative feedback, and therefore the voltage at this node will also be 0.5 times V naught. Now if we mention this node voltage as Vx, which is equal to 0.5 V naught, then we can go ahead with the formulation of the KCL for this part of the network, considering this to be the node. So we can write that a current I1, which is sourced by the voltage source V1, plus the current I2, which is sourced by this voltage source V2, should be equal to 0 milliampere, because this op-amp will not allow any current to enter its input terminal. Therefore, I1 plus I2 should be equal to 0, and then we can formulate I1 as V1 minus of Vx divided by R, and formulate I2 as V2 minus of Vx divided by R, where Vx is equal to 0.5 times V0, which is the voltage at this node, which is the same as the voltage at this point also, and that summation should be equal to 0. So this is that formulation, and we can go ahead with the substitution of Vx with 0.5 V0 and determine the value of the output voltage as V1 plus V2. So this output voltage is the sum of the two input voltages, and there is no polarity inversion here, and so this is an adder or a summer circuit which is non-inverting in nature.